Welcome to today's webinar. My name is Tyler Reid, and I am the Manufacturing Applications Manager here at GoEngineer. Today we are going to be discussing a new certification solution brought on by Stratasys a couple months ago called the Aircraft Interiors Certification Solution. This is tied to the Fortus 900, and it's going to be the first true initiative into end-use parts for Stratasys into the aerospace vertical business unit. It's really exciting for Fortus 900 customers and also probably future Fortus 450 customers and anybody looking into supplying additively manufactured parts that are repeatable and traceable and can pass FAA certification. As I mentioned, this is a strategic initiative brought on from Stratasys into the aerospace vertical business unit. Their goal here is to supply additively manufactured parts to aircraft OEM and aircraft OEM part suppliers. To do that, it requires a much more simplified path to part certification that exists today. It's critical and a requirement that additively manufactured parts are certified for flight, and historically, we haven't had a good pathway to doing that. This pre-certification process is going to increase the visibility of this process, and it's going to decrease the time to market for customers additively manufacturing parts. Another goal of Stratasys with this solution is to establish partnerships to develop materials, systems, and to refine the processes for aerospace providers. Let's talk about a few of the problems that aircraft customers have today. These are some direct quotes from customers who are either interested in supplying additively manufactured parts or are already in the process of doing so. The top complaint is in regards to inventory. These part suppliers are needing to maintain an inventory, and the cost is high to do that. Its cost is high to produce and maintain the parts. A second customer problem is too much time spent on actual assembly of these parts. Aircraft OEM providers are assembling the full-on assemblies and also sub-assemblies. There are delays in product delivery. If additively manufactured parts can potentially consolidate each other, there's going to be room for improvement. And lastly, there's a demand for customization. This demand isn't unique to the aerospace industry. It's a demand that is across the board in automotive and consumer goods and electronics and industrial goods, everything. But it's a great need for aerospace customers. Imagine Delta, United, they want to customize the cabin, provide a unique experience to their customers. Well, that's very difficult to do and it's very costly. So how does AM or additively manufactured parts, and in particular Stratasys, come into this equation as a solution? What do they offer? In regards to the first demand, the inventory, we can 3D print parts on demand and maintain a digital inventory rather than a physical inventory. Your warehouse costs are going to go down and your part delivery time can actually go up. In regard to the second demand, spending too much time on aircraft assembly, as I mentioned, if we can lightweight parts and consolidate parts, we can reduce the amount of assembly actually happening. We can reduce the chance for misassembly. And we can reduce the bill of materials. Consolidation is one of the most important aspects of additively manufactured parts. With 3D printing, we encourage single part complexity. With conventional manufacturing methods, we have to reduce the complexity of every individual part in the manufacturing phase. And then we assemble them together, either through fasteners or welding or adhesives. Well, with additively manufactured parts, we encourage part complexity within our manufacturing process. The more complex the part it is, the more efficient 3D printing becomes. And lastly, the need for customization. When it comes to interiors and personalization, branding, customers will be able to enhance the in-flight cabin experience, really make a unique experience for their users and their customers. Bringing on additively manufactured parts reduces the cost, reduces the tooling, and reduces the time to actually get into customization. One important thing to keep in mind here is that aircraft production parts, they have to be produced with a process that provides extreme consistency and extreme repeatability. If we are going to create an airworthy part, the first part has to be the exact same as the 100th part off our machine. And that 100th part has to be the exact same as a part we produce 10 years from now. And the only way that we can guarantee that is by proper maintenance and evaluation of the 3D printer, proper traceability and accountability for our materials, and proper vision or proper protocols in the actual printing process. When it comes to airworthy parts, whether they're flight critical or non-flight critical, we do require FAA approval for production. The goal of that FAA approval is to verify what we were just talking about, that the manufacturers have established a system that ensures those parts are repeatable and they're conforming to the actual approved design of the part going into service. So what are the challenges in doing that in regards to additive manufacturing? Well, one of the first challenges that AM part producers face is that they have to create their own material design allowables as a data set, as well as prove to the FAA and confirm consistency and repeatability of their AM process. This is very time-consuming and expensive, and it's circuitous, and it's really an unknown to many people outside of the AM industry and even inside the AM industry. So Stratasys' solution to this is to actually provide the design allowable data set for the material, ULTEM 9085. They are also going to provide the hardware and the process and the documentation to qualify Stratasys parts off the Fortus 900. This is going to simplify the process of Fortus 900 users in demonstrating equivalency to the original data set. The second market challenge that AM users face is the current repeatability of our systems. From the difference between system to system and site to site, there's inconsistencies that reduce the applications and the adoption rate of additively manufactured parts in regards to aircraft production. So the Stratasys solution here is based both in hardware and software. They're coming out with a new tip. It's called the T16A tip. They're coming out with updated software with a high quality build mode, which is going to produce more repeatable parts. We'll have 10 times variability reduction, part to part, system to system, site to site. We're also going to have almost a 50% improvement in Z-axis strength. This means the parts are going to be more isotropic and are going to be easier to qualify for critical and non-critical parts. They're also going to come on site and help set up the Fortus 900 and ensure that it's operating as expected, and also advise users on how to maintain and keep that machine running as expected. The last challenge that Stratasys is confronting with this aircraft interiors certification solution is the fact that the customers have to create their own procedures and gather all of the documentation required to achieve the certification. Users of the aircraft interior certification solution are actually going to have the documentation and the process control documentation, or PCD, provided to them. Things like material specifications, process specifications, and even CMB print files are going to be provided. That's going to save time and money when it comes to actually implementing a process and pursuing AM parts for flight. So really the goal of this certification process is that it's going to act as a pre-certification process that shortens the time to market by simplifying the route to FAA certification. You know, every aerospace production part requires full part traceability. And historically, this has been very difficult to provide, especially with some of the consumables like the tips. It just didn't exist. So within this solution, there is going to be changes made to that, and there's going to be other options made available. So let's talk a little bit about exactly what this aircraft interiors certification solution actually entails. There's 4 parts to this solution. The first part is a Stratasys on-site qualification support. This is going to be a key component to quickly and effectively qualifying the actual machine, the Fortus 900. The second component is maintaining the Fortus 900 and the material, ULTEM 9085, and also consumables like the tips. The third leg of this solution revolves around documentation and B-basis design allowable datasets. All of the necessary documentation to apply for certification. There's going to be a little bit of hand-holding from Stratasys to help you navigate the certification process for an additively manufactured part. And then the last component of this is another hardware component. They're calling it the equivalency toolkit. It's essentially measuring devices to verify and maintain the Fortus 900 for certification. So we're going to go into each one of these a little bit deeper here. The Stratasys on-site qualification support, as I mentioned, this is going to be key in getting your machine up and running properly. It's going to include 3 days of Stratasys on-site support. They're going to be completing the PCD documentation line by line with the customer. They're going to validate the initial system setup, operation, and calibration. And they're going to train the customer on the process for ongoing system checks. The second component, the B-basis design allowables dataset. This is in regards to the Fortus 900 and the material, the ULTEM 9085. With an improved certified process, products designed using the B-basis design allowable dataset for ULTEM on a qualified Fortus 900 will be capable of producing parts for certified aircraft applications. Up until now, no public additive manufacturing B-basis design allowable dataset has actually been created. So an industry group chartered by America Makes selected 9085 as the appropriate material to produce and implement and pursue wide acceptance of additive manufacturing in the aerospace community. Let's talk a little bit about ULTEM 9085. ULTEM 9085 was launched in 2015. We do have a traceable version of this material. It comes in the natural color only. The black version of this is not traceable. Traceability of both the lot and the batch comes from the manufacturer, which is SABIC. The material itself is strong, lightweight, and flame retardant. It's widely used in aircraft interiors today. The material has a V0 rating for flame, smoke, and toxicity. It's a certified material that's qualified against a controlled specification to ensure consistency of quality and material properties on the part level. This material in particular is available on the Fortus 900, the Fortus 450, and the oldest Fortus 400 machines. It's used throughout the aerospace industry already by companies like Boeing, Lockheed Martin, Airbus, ULA, Embraer, etc. And let's talk a little bit about the Fortus 900. The Fortus 900 has been the flagship FDM machine now for quite a while. Has several different materials depending on what your goal is. Obviously for end use aircraft parts, we're looking at ULTEM 9085. But it also prints in PLA for concept modeling. It prints in materials like ASA and PCABS for high-end prototypes. It's easy to use. It doesn't require a dedicated operator. It uses our new GrabCAD print software, which requires nearly zero training, has an excellent interface, and is just simple to use. It has automated calibrations, it's Wi-Fi ready, USB enabled, and remote monitoring built into it. The new version has high-speed mode, draft mode, which is 2 times the speed of some of the older machines. In terms of performance, part repeatability, accuracy, and machine reliability, again, it's unrivaled in the additive manufacturing world. And it is the clear choice for end-use FAA certified airworthy parts. Now with that Fortus 900, the way it operates, it uses consumable tips. These tips last anywhere from 1,500 to 2,000 hours of print time. And then they're replaced. This has been a pain point for customers pursuing FAA certification for their part production. Historically, these tips have not been traceable. Well, that is ending with the T16A tip. So there are some physical changes to this tip that make it unique, and there are also some process changes. With this tip, we're going to have a much lower coefficient of variance, especially when used with the high quality build mode that's default for this tip. So it's more repeatable. We also have traceability, which is controlled for production use. This tip is only going to be available for Fortus 900 customers, and it will only be used with the ULTEM 9085 material. One of the last components of this certification solution is the equivalency toolkit. As I mentioned, it's going to be required that the machine operator verifies and maintains that the machine is operating as expected. That's going to require some measurements and some special tools. These are those tools and the guidelines for taking those measurements. So the customer or the user does not have to go out and buy and assemble this toolkit. It's just built in and provided right away as soon as you sign up for this aircraft interior certification solution. So where does this certification solution fit in the steps to actual manufactured certified aircraft parts? As I mentioned in the beginning, it really is a pre-certification process meant to ease the actual certification process. So we have several steps here. The Stratasys solution is the first step. It's helping develop the aircraft part production process. It's Stratasys coming online, helping qualify the actual machine, providing the qualification documentation and the toolkit to continue verifying and maintaining the machine, and providing the machine and material. Once the user is up to that point, they're actually going to start printing and testing coupons to validate and prove equivalency of their parts. After validation, the AM production process is going to be ready for submission to the FAA for certification. Once that certification process happens, then we're going into production. And this is where continued maintenance and evaluation of the machine and the provision of certified and traceable materials from Stratasys comes into play. They're going to be able to support actual production volumes. Once those parts are produced and they are proven to be equivalent, then they can be installed on the aircraft. So this slide makes the process look simple. I think everybody on this webinar knows it's not quite that simple, but hopefully with the experience that Stratasys has within their aerospace division and the experience that they have working with the FAA and large aircraft OEMs, they will be able to provide the hardware, the software, the documentation, and the experience to help guide our customers and our users. So that's a quick overview of that aircraft interiors certification solution. Again, just as a overview, it's a pre-certification process. The goal is to shorten the time to market by easing their way through the FAA certification process, providing everything we can up front so that the actual manufacturer comes into the FAA prepared. So I want to thank you guys for joining. If you have more questions about this process, feel free to shoot me an email, treid@goengineer.com. You can hit me up on LinkedIn as well. Happy to provide more information and connect you with Stratasys directly to pursue this solution. Thank you guys for joining, and take care.